All right, hello everyone. Today we'll be talking about dilations. So a dilation is a change in size where the image shrinks or stretches. So it's getting bigger or smaller. And change happens in respect to a fixed point. So we will be doing our dilations around the origin, but you can actually dilate around any point on a graph. The scale factor tells us how much bigger, how much smaller the image is getting, and that is the ratio of the new side length of the figure to the original side length. And then in order to do these dilations, the easiest thing is to multiply both coordinates by the scale factor. So please pause the video, copy this onto your worksheet, and when you're ready, we'll do an example together. So we're going to look at this first example where we are dilating by a scale factor of 2. So what I like to do first is I like to go through and identify each of my coordinates. So point A is at -3, 0. Because if we're starting at the origin, we're moving 3 units to the left, so that's a -3, and 0 units up and down. Point B is at -1, +2, because we're going 1 to the left and up 2. Point C is at 2, 3, because we're going to the right 2 and up 3. And last, point D is at +1, because we're going to the right 1, and -2, because we're going down 2. So in order to find the new figure, all I have to do is take each of these x values and each of these y values and multiply them by the scale factor. Since my scale factor is 2, I just multiply both values by 2. So that makes my A prime a -6, 0, because -3 times 2 is -6, and 0 times 2 is 0. B prime will be -2, 4. C prime will be 4, 6, and D prime will be 2, -4. And again, that's because we multiply 1 times 2 to get 2 as the x value, and -2 times 2 to get a -4 as the y value. And then I can go ahead and plot each of those points on my graph. There's A prime, B prime is -2, so left 2, +4, 1, 2, 3, 4, up 4. C prime will be at +4, 1, 2, 3, 4 to the right, and up 6. Right here, just below the 2. And then D prime is +2, and 1, 2, 3, 4 down. So D prime is here. And then I can go ahead and connect my dots. This point right here along the y-axis will also be helpful to have, and since I go 1 up, in order to double that, I have to go 2 up. And last, connect here. And so these figures will be similar because the shape is the same, but the size is different. And I know it doesn't look like it because drawing on the iPad is hard for me, but the angles in both shapes are congruent. So go ahead, pause the video, work on the next 2 dilations, and then we will go over how to identify a dilation. All right, so I'm going to go over the example in the middle. So it's asking us to find the scale factor, so we have to figure out how much bigger or smaller the image is getting. And so in order to do that, the scale factor is the ratio of the new side length to the original side length. So I know my new figure has these primes, so this length right here is my new length, which is a 3. This length up here is the corresponding side, and since that figure does not have primes, that's my original, and that is 1, 2, 3, 4, 5, 6 units long. So that makes my scale factor 1/2. I can also check the scale factor by looking at some coordinates. So if I look at b prime, that is over 2 up 1. And then if I look at b, my original, that's over 1, 2, 3, 4 up 2. And so the ratio of my new coordinate to my old coordinate is also 1/2. So that shows us some patterns. So we know that an image gets bigger if the scale factor is bigger than 1. So even if it's a decimal or a fraction bigger than 1, it's going to get bigger because both the x and y coordinates are getting bigger. Actually, in the negative values, they're not getting bigger. The absolute value is getting bigger. And then an image is getting smaller if the scale factor is between 0 and 1. So any fractions in between 0 and 1 will make our image smaller. Just like here, we had a scale factor of 1/2, and it got smaller. Continue working on the worksheet, and anything that you have questions about, we can go over on Monday. Hope you have a great weekend.